All right, what's up everybody? Today I was just thinking that it would be fun to do, we've been doing all of this Tone.js stuff in the web browser, which is great and all, but sometimes we want to actually, have something a little bit more performant, like being able to control Tone.js with a MIDI keyboard or something. Instead of using a MIDI keyboard, today I'm going to be using this right here. This is a MIDI controller. It's plugged into my computer right now, but it's got all these knobs. It's got little faders, and it's got buttons on it too. And what's really cool about the web is that there is an API, just like there's an audio API, web audio API. There's one for the MIDI controller as well. And so what we're going to attempt to do here, I don't know if it's going to be more than one video or just one video, is get access to a controller, a MIDI controller with the web browser, and have it control audio. All right, so let's just get into it. This is CodePen. And if we want to access the MIDI controllers here, these guys, for those that don't know, a MIDI controller is basically a thing that triggers events, and it's used commonly in music production or whatever, in different music software. But all it is basically an event with a bunch of different events for a bunch of different inputs that all have a value between 0 and 127. So let's get into it, and we'll start seeing this. You should be able to use any MIDI controller for this if you're doing this on your own. Yours is going to look different and behave differently, but you'll get the gist. All right, so in order to access MIDI controllers, we have Navigator, and this is only going to work in Chrome right now, I'm pretty sure. Request MIDI access. Then console.log. Yo, let's see if this works right here. Perfect. Okay, so what this is going to give us, it's a promise. That's the calling request MIDI access returns a promise, which means we have .then and .catch. We'll just say console.error. Catch is the exception handler. But the promise should give us access. And let's just take a peek at this. So here we go, MIDI access. So we'll see here that we have an input with a size of 1 and an output with a size of 1. Now these are iterators. The MIDI input map is an iterator, which is newfound JavaScript land here. Let's just say access.inputs. Whoops, we're going to log that. And so here's our MIDI map. I'm going to console.clear. All right, so here's our MIDI input map. So you can see we have a property of that, but with an iterator, we should be able to just say values. These should be, let's do, oh, this is the iterator. I get it. So if we say, sorry, inputs isn't an iterator. It's the values are the iterator here. So if we say const, let's just say devices. So this is supposed to give us our devices, because we could have more than one of these plugged into our computer. And so I'm going to say for let device of devices, let's console.log device. Thanks for bearing with me there. Let's see. Here we go. All right, so here's our MIDI input. So that's this dude right here. So we can see that its manufacturer is Korg. It has an ID, and its name is the Nano Control Slider Knob. So this is that's the name of this model of MIDI controller. So yours will say things different for all of this. but we can see that it is connected and it has a type of input, and the connection is currently closed. And so then what we can do, let's see here. When we initialize this, we should be able to say, so this is our device, device.on, how do you spell it? My bad. On MIDI message equals, let's just have on MIDI message function. So down here, function on MIDI message, we're going to get a message. Let's just message. I can't save in presentation mode. That's annoying. All right, so we need to send some messages. So I'm just going to press this button right here. Oh, we got 2 message events. Let's look at them. So we have one right here that has, here's our target. That's the device that we had earlier. Look at data here. So what this represents, if I'm not mistaken, I forget what this first value is. It may be attack or something, or velocity. I can't remember, but this position in data, so that's what, when I press that button down, this event happened. And so this 23 right here, that refers to the ID of the input in the entire device. So every input on this thing has its own unique number. And so that's what the 23 is. So I hit button number 23, and this is the value, 0 to 127. It had a value of 127. The cool thing here that's unique, sorry that we can't fully see here. Let me just get some returns. Can I just, there we go. So check out this data. So this is when it came up. So we pressed down and that first event fired. Then when I released it, the second event fired. So we'll see here data 23, that's our ID, and then 0 was the value. And so in the case of a button, it can only be 0 and 127. So 127 is when it's down and 0 is when it's up. So just to clarify this here, we're gonna look at let's say we don't care about the first position. The second position is going to be the input, and then the third item in the array is going to be the value. Equals message.data. This is a cool thing. So this is saying, hey, message.data is an array. Message.data is an array. And then we're going to name each of the positions here, 0, 1, and 2, with variables. So what we can do now is say input, and we'll make this an object, value. So now when we'll run this, and so now when I press, I'm only going to show you on screen a couple more times, this is getting annoying, down, up. So we have input 23 with a value of 127, which means we pressed it. And then input 23 with a value of 0, which means we let it off. So now I'm going to twist a knob here, and we can see, oh wow, what's this? I'm just twisting it back and forth. So that knob has an ID of 14, and you can see that its value is incrementing and then decrementing, if that's the term. So the value goes from 0 to 127 and then back down to 0 when I turn it up and down. So we are getting data from our MIDI controller, and let's quickly wrap this in a class to make this kind of a little bit more of a component. So I'm going to just say here, class MIDI access. So we'll wrap this logic in a class, and then we'll have places where we can grab these events and stuff. So to start in our constructor, I think I'm just going to name, let's do this. We're going to have args with a default of empty. And there's going to be, well, first let's just do devices. So our devices, remember our device has an ID and then some values, like a name and a manufacturer. That all represents this. Those are going to go in this devices object. And then we will do it on device input equals args dot on device input or console.log. So this is going to be a function that will pass into the constructor when we build this class or build an instance of this class. And all it's going to be is the function that we call whenever the device gets an input and sends an input. Because we're going to need that. That's going to be the point at which we engage with the data that's happening. All right, so then let's make a method called start. And this will be requesting access like we're doing down below. In fact, I'm just going to move. We're going to move this up here. And let's actually put this in a class. So request access. And let's make this a promise. Request access, return new promise, resolve and reject. I don't know if we've gotten into this before, but all a promise is it's something that could take some time. And so we want to make sure that it completes before moving forward. And that gives us the .then and .catch, which we'll do up here, just to .then, boink, .catch. Just as a reminder, we're going to put some stuff in here later. But so we're going to return a new promise. And so we'll request access. And then, boom, 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 boom. Actually, let me check what I did earlier. Yeah, you know what? This is actually going to be perfect. This will make more sense in just a second. So we're going to request access. Then we're going to resolve the promise if that succeeds. Otherwise, we're going to reject. So basically what we're saying is if this is supported, which I think right now will only be Chrome, if you're using Firefox or Edge or anything, this should be false. And so we won't be able to do this in those browsers. But we'll say if this method, request MIDI access, exists on the navigator, request that access. If there's any failure, reject. Otherwise, resolve. So up here, what we're going to do is say, instead of this, and I think this should return a new promise too. You'll see in just a second. Resolve, reject. Let me just actually see what I did earlier. Yeah. So then what we'll do is we'll initialize our entire thing, and then we will resolve. I'm going to cut this and we'll use it in a second. Otherwise, reject. And actually, let's do a function here. Reject something went wrong. All right, so then we need an initialize function. And we're going to pass in the access. Perfect. And then we're going to do a this.initialize device. So for every device we get, we're going to initialize the device. That's going to take a device. Yep. And let's just spoof something here. So we have this on MIDI message from earlier. I'm going to cut this. On MIDI message. What do we call it up here? On device input. Let's just say this will be on message. This dot on message. And we need to bind this. And then on message, it's going to take the message, it's going to log that, and then it's going to call this dot on device input. And let's just pass in the input and the value. And that doesn't save. Cool. All right, so let's recap because that was a little crazy. I'm gonna open this up. So we have a new class here called MIDI access. The whole point of this is going to be to return, is to basically handle all the setup stuff for us and then tell us when something happens. Like whenever I press a button, this thing will tell us. So what we're doing is we are creating, and you know what? We have this devices object that we aren't setting. Inside of initialize device, this devices device.id equals device dot let's just say name, device.name, whatever. Let's not even store. We don't even need to store devices right now. That's just making things more complex. So we have our constructor that's going to take an on-device input. And if that isn't present, then it's just going to use console.log. And then we have the start method, which is going to be called by us outside to start this thing. And that returns a promise that gets the access to the device and then sets up all the devices for us before resolving. When it initializes a device, it just sets the on MIDI message to be this on device, to eventually call this on device input through this on message thing here. So let's just look at it. So we're going to have this. So we're going to say const MIDI equals new MIDI access. And then we need on device input. Let's just name a function that. So function on device input. Remember, this is going to take what's it passing through an input and a value. So we're just going to say input value console.log on device input, and then let's just do input value. So now MIDI.start. Remember, that returns a promise. So .then, this is when the promise resolves, console.log started, and then .catch console.error. Let's see what happens here. Undefined is not a promise. Inside of start. Request access. Then initialize. Promise. Undefined is not a promise. Maybe one of you is all about this here. Does one of you know exactly what's going on? Start is returning a promise. Oh, return new promise. There we go. Bingo. So we started. So now that was this line right here. And then since we passed in this function on device input, when we press a button, so here it comes, on device input, there it is. And then let's just, yeah, move a slider around. Beautiful. All right, so this is good to go. So now, at this point, we can start mapping this over to Tone.js. So I am going to bring in Tone.js. Yeah, that's all we need right now. Okay, that whole thing wasn't saving until now. Yikes. All right, so we have our doohickey. Let me just refer to this other stuff that I was making here. All right. So our MIDI access is set up. I'm going to collapse that for now. I think the next thing we should probably do is create our instrument. So this is the doohickey that we're going to control here. So let's set up our constructor. Let's just define what we're going to have here. We're going to have a synthesizer. Let's just say this is a new Tone.PolySynth, which is something we haven't covered yet. I'm going to do this a bit differently than I have been in my notes. So the PolySynth takes voices. So that's how many. So the synths we've been using up until now are monosynths, which mean only one note on them can be played at a time. So if I'm holding a C and then I press a higher C, the higher C is going to start playing instead of this C. This C will stop. It's a monosynth. Only one note can be played at a time. With a polysynth, you say how many notes can be played at once. And that's what this is right here. So this 3 says this could be 8 or whatever number you want. And so I'm saying we're going to have a polysynth that uses Tone.FM synth. Remember, we have FM, AM, normal synth. This is saying what do you want to use for that? And so now what our synth will be able to play 3 notes at once. Just to hear it. Some of the methods are different for a polysynth than the other synth. Like setting attributes of the synth is a little bit different, which we'll get into. But let's just trigger attack release. And if you remember, like attack release in the past, we were doing like C4 for a quarter note, and then we're passing in time or whatever. But here with a polysynth, we can actually bring an array in. So let's just say E4, G4. So that's a C major chord. And so we're going to play all 3 notes at the same time. So when I do const inst equals new instrument, this should play a sound. Get ready. Oh, no it's not. All you are like, to master. Never forget, we have to connect it to master. There it is. It's kind of crazy. So we're playing a C major chord. I don't know how well you can hear that, but. So that's our polysynth. Let's think of all the things we want to control. I say we control the, let's have a volume. Let's have like one of these knobs, or maybe this slider will control the volume. And then maybe this one will control a filter, which we'll get to here. This knob will control a filter. This slider will control the volume. This button will play a sound. And then maybe we'll like have another slider that changes the chord. We'll get to that. So for now, let's stick to the volume, playing the sound, and the and a filter. Okay, cool. Let's just write out what we got here. So we're gonna have a filter equals a new tone.filter. I'm pretty sure. And then we're going to have a volume, which is a gain, or well, volume equals new tone.gain. Beautiful. And then let's connect this stuff up. So filter is an effect. We'll put that before the volume. So this dot synth dot connect this dot filter. All right, so we're going synth into filter, filter into gain, gain into our amplifier. So then this dot filter connect this dot volume, and then this dot volume dot connect, or no, to master. Beautiful. I'm curious if this is, okay, so that filter is on. Let's not trigger this until after. Let's see what happens here. Okay, so the value we're going to control on filter, just for our reference, is this dot filter dot frequency. So picture the filter just kind of like cutting off. It's low pass by default, so I don't know if it's going to work in the video image, but you know, low pass means the low end. Yeah, this would be the low end to you. So low end, and then it kind of cuts off on the high, and so then you can move that forward and back and sweep. So the frequency is where it's going to be on the frequency spectrum. So let's just say that's between 200 and, this is just a comment, it's going to be like roughly between 200 hertz and like, let's just say 15,000. And this is going to be a linear thing. We don't need to, we're just going to have the knob go between those two values incrementally. We're not going to try to, whatever, it's a whole thing in audio, but basically the hertz, the difference between notes gets larger in hertz the higher you go. And we're not going to worry about that scale. We're just going to move it linearly between the two numbers. If you don't know what I'm talking about, don't worry, you don't need to. Let's just say right now that the frequency is at 200 and hear what that sounds like. And then what happens if I put it at 15,000? Nope. I think we have to say frequency.value. There it is. So we can hear all those highs now. I don't know how obvious that is, but the difference between that and this. You hear how all the highs are cut off? That's what we're doing with our filter here. And I think, you know what? Let's just set the Q, which is the sharpness of it, to like 1. I think that's a 0 to 1 range. I don't know, maybe I'm not doing the right thing here. Maybe the Q is just fine. Yeah, okay, I'll take that out. Forget I said that. If you want to know more about that stuff, filter on the Tone.js docs. Here's our Q. Oh, Q's defaulting to 1. That's why it didn't sound different. Here's our frequency. The roll off is like how much. This is like an octave. It's like how much is cutting off. All right, so we're doing a low pass filter. This is set. Cool. Let's just start it off at 200. So that's one thing we're going to change. And then we're going to be changing this dot volume dot gain dot value. So right now it's set to 1, but we should probably not even let it go that high. We should probably just say it's like 0 to 0.8 or something. That'll be our scale. So let's set it first off to 0.8. And that'll be the maximum. Alrighty. Oh, and then we're gonna, so we have volume, we have filter, and then we have playing the actual note. Perfect. All right, so now that we're here, let me save this the old-fashioned way because Command S is not working. And what we're gonna do is let's have a play function. So, because that's what's gonna happen down here. Let's actually do, let's just say toggle. Because what's gonna happen is we're gonna get one event for down, and then we're gonna get another event for up. So what we're trying to control right now is this puppy right here. So when it goes down, we want to trigger attack, and then when it goes up, we're gonna release all is the method for a PolySynth, and that releases any fingers that are on the keyboard. So, because we don't want to hit play on every event for that button, we only want to hit play when it's down. So I'm thinking about doing this in a single method versus two different methods. Let's just call it toggle for now, and let's just get, we'll have the value, which will either be 0 or 127. 127 is when it's held down, 0 is when it's released. So if, let's say, let method, so this is gonna be the method we're calling, equal, value is equal to 127. Yeah, if the value is 127, then we're gonna do trigger attack, else release all. So when the value is 0, it'll be release all. When it's 127, it'll be trigger attack. And so then we'll say this.synth, we're not going to trigger attack release anymore. We're just triggering attack method. And then we just pass in, there's no time for trigger attack, or there's no length for trigger attack. So we're going to pass in a C major chord when toggle is called. So to test this, first of all, we should probably get the ID, right? The input number. Remember the unique number for the button. So when I hit this, we're seeing that it's 23. So this is the button we want to use. 23 over here, right down here. This 23, it means this button is pressed. So down in our on-device input, we're going to say if input is equal to 23, we're going to say inst dot toggle. Let's just call it like toggle sound value. Toggle sound. You doing all right, doggy? Just coughing a little bit. All right, so we're going to toggle the sound on our instrument, and we're going to pass in the value. Booyah. Okay, and then let's, we'll keep logging. We'll just say else. All right, so let's check this out. That's doing it. So what we're doing is we're saying when the input is 23, which is this button on our device, toggle the sound with our instrument. So then in toggle sound, we're looking at the value, which you remember is either 0 or 127 for a button, nothing in between. If the value is 127, that means it's pressed down, so we want to trigger attack with our synth. If the value being passed in is 0, we're going to release the instrument and take our hands off the keyboard, so to speak. And so then we pass that method here. So this is the same thing as saying this.synth.trigger attack, and then we pass in our chord. Now, just to show you, if I hold this down, it's going to keep going. Because our 0 value, which occurs when I release the button, is the thing that turns it off. So All right, that's great. In fact, I can hold this down. I'm holding this down. I'm going to press other buttons. There they are. And then that still works. So anyways, it's kind of cool, right? Beautiful. So we're making our noise. Now let's control the filter and the volume. I don't know how I'm doing on time, but whatever, we're good. Sorry if this is getting long. So let's control the filter and the volume. So volume, I'm going to use this slider for. So down and then up. That's going to be, so that looks like it has an ID of 2. That's the input number. So else if input is equal to 2, toggle handle volume. So let's put handle volume in here. And so this value, remember, is going to be 0 through 127. So we want to turn that into a ratio, right? So we're going to say let val equal value divided by 127. So that'll give us a decimal, which is what we want to set this over here. But we actually want to multiply that by 0.8. Remember, because our maximum value is going to be 0.8. So we turn this into a ratio, that's 0 to 1. Then we multiply it by 0.8, so we're going to get 0 to 0.8. Perfect. And then all we have to do is set the gain value to be the val. All right, let's run this. So that's going to be our slider here. So I'm going to set it. Here we go, kind of like a keytar. All right, so playing, you can't hear it, but you can. All right, we got volume going. Booyah. Okay. I've got like 90s commercials in my head. I keep saying booyah. All right, the other one we want to do is this knob, and that's going to control our filter. So let's see that going. That's going to be very similar here. So let's do if input is equal to 14. We're getting the 14 from those tests right here in the console. We're going to say handle filter. We're going to pass in the value. And this is also going to be 0 to 127. Except instead of multiplying it by 0.8, remember we want 200 to 15,000. So what we'll say is we'll multiply that by 14,800, which is 15,000 minus 200. Then we just add 200. Easy. Filter dot frequency dot value equals val. Is it that easy? I think it is. That's it. All right, I'm going to turn the volume down a tad. Perfect. Awesome. So we are, I can change the volume. I can also change the filter. All right, so I think I'm going to end it there for now. But yeah, I mean, not too much code. We have MIDI access, which gets us access to MIDI devices, right? That's this code up here. And then that code takes a listener to handle the input. And then what we're doing is we're listening for those inputs, and we're mapping those to methods in an instrument that we created with Tone.js. All right, I think that does it. I might do some more stuff. You know, you could build a UI for this. I might record a video with a UI for it in a little bit or something, or just do something else. But yeah, hope you enjoyed it. Keep going. Gets easier. Talk to you later.